So in this video, I'm going to show you how to integrate with partial fractions and inverse trig functions. So in our first question, we have the integral of 9x minus 6 all divided by x plus 2 multiplied by x squared plus 4, integrated with respect to x. So the first thing I'm going to do is I'm going to break this up using partial fractions. So say this is the integral of a over x plus 2 plus bx plus c over x squared plus 4. If you notice, this quadratic has no factors, so we have to write the numerator as bx plus c. And this is all integrated with respect to x. Okay, so the next thing I'm going to do is I'm going to forget about the integral and focus on working out a, b, and c. So we'll say 9x minus 6 over x plus 2 multiplied by x squared plus 4 can be written as a over x plus 2 plus bx plus c over x squared plus 4. And now I'm going to multiply every term by this denominator, and it will cancel then off the left-hand side. So we have 9x minus 6 is equal to a lots of x squared plus 4 plus bx plus c lots of x plus 2. Now the easiest thing I can do is to let x equal negative 2, and that will cancel out this bracket here. So we'll say let x equal negative 2. We'll put negative 2 into our left-hand side, and we get negative 24. With negative 2 into here, and we get 8. So this is equal to 8a, and this has cancelled to make 0 because of this term here. So now we know that a is equal to negative 3. So to work out b and c, we need to equate coefficients. So we know the 9x we can use as 9x, and this is obtained by multiplying the bx by the 2 and the c by the x. So this is equal to 2bx plus cx. So therefore, we'll cancel out the x's. 9 is equal to 2b plus c, and we'll call this equation 1. The next one, we know this negative 6 we can use, and this is when we multiply the a by the 4 and the c by the 2. So negative 6 is equal to 4a plus 2c. And we know that a is negative 3, so this bit becomes negative 12, which then gives us that c is equal to 3. And now we can substitute c equals 3 into equation 1. And this will give us 9 is equal to 2b plus 3. So therefore, b must also equal 3. Okay, so now we have a, b, and c. We can rewrite this integral. So we'll copy this, and we'll replace a. We'll replace a, b, and c with a equals minus 3, b equals 3, and c equals 3. And I'm going to write this integral now as two separate integrals. So this is the same as minus 3 times the integral of 1 over x plus 2, integrated with respect to x, plus the integral of 3x plus 3 over x squared plus 4 with respect to x. So I'll do this one in yellow, and I'll do this one in green. So now we know the integral of 1 over x plus 2 is a ln function. This becomes minus 3 ln of x plus 2. And the green part becomes the integral, and I can split up the x and the 3 terms. So 3x over x squared plus 4 with respect to x plus the integral of 3 over x squared plus 4, again with respect to x. So this one, I can take this 3 to the outside. So the integral of 3 of x over x squared plus 4. And again, we can use the reverse chain rule, because the derivative of x squared is 2x, so we can scale to get the numerator. So this will give us 3 over 2 lots of the ln of x squared plus 4. On the right-hand side, we can take out the 3 again, and this will give us 1 over x squared plus 4. Now, for this one, we need to integrate using the reverse tan function, which is 1 over a squared plus x squared with respect to x is 1 over a arctan of x over a plus a constant. So we need to identify that in this case, the a squared is for 4. I'll write this down. A squared equals 4. So that means the a must equal 2. And I can substitute this value of 2 into our integral. So we have 1 over 2 arctan of x over 2. Okay? So now we need to put these 3 parts together. So a final integral is minus 3 ln of x plus 2 plus 3 over 2 ln of x squared plus 4 plus 1/2 of arctan of x over 2 plus the constant c. Okay? So that's our first question. Let's try one more. Okay, so in our second question, now we're going to work out the integral of 8 minus 3x over x plus 2 multiplied by x squared plus 3. Again, integrated with respect to x. So again, the first thing I'm going to do is I'm going to break this down using partial fractions. We'll say 8 minus 3x over x plus 2 multiplied by x squared plus 3 is equal to a over x plus 2 plus bx plus c over x squared plus 3. So we'll multiply both sides by this denominator. So we get 8 minus 3x, because it will cancel from the left-hand side, will equal a lots of x squared plus 3 plus bx plus c lots of x plus 2. So now we can cancel out this x plus 2 term by saying let x equal negative 2, which means this part will become 14, 8 plus 6, and this part will become 2 squared, add 3, which is 7, so 7a, and this part will cancel. So therefore, a must equal 2. Now, to work out b and c, we need to use equating coefficients. And we know we have a 0 x squared term. So now the x squared term is made from ax squared plus bx squared. So we can say that 0 x squared is ax squared plus bx squared. We'll cancel out the x squareds, so 0 is equal to 2 plus b. So therefore, b must equal negative 2. And the next one we can do is use the coefficient of x, which is negative 3. So negative 3x is equal to the bx times 2 and the c times the x. So negative 3 is equal to negative 3x is equal to 2bx plus cx. We'll cancel out the x's. So negative 3 is equal to negative 4 plus c. So therefore, c must equal 1. Okay, so now I'm going to rewrite the integral. We know the integral of 8 minus 3x over x plus 2 multiplied by x squared plus 3, all with respect to x, is equal to the integral of 2 over x plus 2 with respect to x plus the integral of 1 minus 2x over x squared plus 3, again with respect to x. Okay, so first thing I'm going to do is I'm going to work out this bit first. So we have the integral of 2 over x plus 2 with respect to x is equal to 2 multiplied by that integral. I'm just taking out that multiple of 2. And I can use the ln of a natural log function to integrate this. And then I get 2 times the natural log of a magnitude of x plus 2. Okay, so that's the integral of this. So the next one, we're going to go back and look at this part in green. So we have the integral of 1 minus 2x over x squared plus 3 with respect to x. Now I'm going to break this down by taking out the x and a 1 term. So we have the integral of 1 over x squared plus 3 minus, and I'll pull out the 2 to the front, so 2 times the integral of x over x squared plus 3, again with respect to x. So if you remember our inverse trig function, where we had the integral of 1 over a squared plus x squared with respect to x is 1 over a arctan of x over a plus a constant, we can see that this form matches this form, where we say that a is equal to 3, a squared is equal to 3, so therefore a must equal root 3. And now I can substitute this value of a into this formula here. So this becomes 1 over root 3 arctan of x over root 3. The constant I'll carry on at the end. So I'm just going to put a little box around that so I don't forget. And that's the integral of this part here. Okay, so for the next one, so now we're going to integrate this bit. And you can see we've got the reverse chain rule, where the derivative of x squared can be scaled to make the x term. So we have 2, we'll have a negative 2, times 1/2 of a natural log of x squared plus 3. So this 1/2 comes from, when you differentiate this, you get 2x, but you need to cancel out that 2, so you multiply it by 1/2. And then when you multiply this half by the negative 2, you get negative ln of x squared plus 3. Okay, so now we've got the negative, we can move this over to here using the power rule. So we get negative 1, which means we can write this as a fraction. We have positive ln of 1 over x squared plus 3. So all I've done is I've used the power rule to move this negative over to here, and then I've rewritten that as a fraction. And again, I'm going to draw a little box around this, just so I know it comes from here. Okay, and this one also comes from here. Okay, so now we can finish this off. We have this bit here, which is this. So we'll say the integral is equal to 2 ln of x plus 2 plus, and I'll write this bit next, the ln of 1 over x squared plus 3 plus 1 over root 3 arctan of x over root 3 plus the constant. So finally, we can use the rules of logs to move this 2 over to here and to put these two together using the multiplication rule. So we have a ln of x plus 2 all squared over x squared plus 3. So again, putting this 2 over to here using a power rule, and then multiplying these two together because they've got the same base of e. And then plus 1 over root 3 of arctan of x over root 3 plus the constant c. Okay? Thank you for watching, and I hope you found that useful. You can check out the full lesson and worksheet from my website, mrmathematics.com. Thanks again, and take care.